G Prime's tutorial, online tutorials. We are here to help you with your academics problems. If you have any problems, you can drop it in the comment section below. Do well by liking and subscribing this video. So we are going to be continuing from where we stopped in our last video, because we made reference, we were able to discuss about differentiation. We said there are two methods of differentiating a variable. So we have the first principle, differentiation using the first principle, and we have differentiation using the general rule. And we're able to see that we differentiated variables using the general rule. If you didn't watch it, you can go back. We have a link here for the previous videos. You can go and watch them. Do as well to like, comment, and share with friends. So without wasting much time, we have differentiation using first principle. In differentiation using first principle, there's also a general formula that we have to follow. We have to follow this general formula that satisfies this equation that says dy of dx is equal to limit as dx tends to 0 of what? F of x plus dx minus f of x now all over dx. So now this is the general formula for differentiation using first principle. So whatever you are being given as your question, the question must be able to satisfy this particular formula, and I'm going to show you how we are going to differentiate the variables using first principle. Stay tuned as you watch this. Now here we go. Let's say for example, and then there's one thing you also need to put into consideration. Once your question is specific, differentiate the given the following variables using first principle. You have to use first principle. Once they said using general rule, you have to use general rule. But the easiest method is differentiation using general rule. And then we said there was a general formula. We said using differentiating using general rule. We said your equation must be able to satisfy your dy dx, which is equal to what? N ax n minus 1. This was the general rule we used before we dropped this. And now I said, for example, you're going to take one example. Let's say find the differential example. Find the differential coefficient of x squared, y equal to x squared, using using first principle. So when the question is specific that you should find the differential coefficient of y equal to x squared using first principle, you must definitely use first principle in solving it. But first of all, just look for a space in your booklet or your answer sheet or whatever you're using to solve, or your rough book. You can just get a place and then differentiate using general rule. Once you've gotten your answer, then whenever you're differentiating using first principle, you are trying to work towards the answer you got. Like now, using general rule, I'm differentiating x squared, f of x. Differentiating once, like we said in the previous video. If we're differentiating once using x squared, now how do we do it? We said the coefficient, the power here, n, is what? 2. So it's going to be 2 times, what's your constant? We said there's an invisible one here. 2 times 1 times what? X raised to the power of 2 minus 1 is going to be equal to 2x raised to the power of 2 minus 1 is 1. So this is your answer using general rule. But then your question was specific. You should use first principle. You can only do this in order to get your answer and keep it aside while you work towards it in the first principle. So now we said we are going to find the differential coefficient using first principle now, and we said it must be able to satisfy this equation that we've given here, we've derived. So now from here they said your y solution, we said our y is equal to what? X squared. If you remember, That's why I refer you back to the first video we did on functional notation. If you could remember, we discussed about functional notation, of which we said this can be represented as what? F of x to be equal to what? X squared. That means this f of x signifies what? The functional notation of x. It doesn't make any difference with this question. So if I write it like this, I mean I should differentiate with respect to x once. That was what we discussed in the earlier video. But this is not what we are really interested at now. We are interested at this now. So if we said that f of x is equal to this, now we are trying to make this equation look like this. Are we following? Now we said dy dx now. Dy dx as your limits of dx tends to what? 0. Then, okay, before then, our f of x plus vx will now be equal to what now? Now, watch carefully. We said our function of x is equal to x squared. Now, your f of x, that's this now. We've already gotten this. That's your function of x because we are substituting back into this formula. So now your f of x plus dx signifies that wherever you see x, you substitute it with what? X plus dx. Just like we did here. Wherever you see x from the question now, you substitute it with what? X plus dx. So we've seen x here. Now it's going to be equal to open bracket x plus what? Dx. All what? Squared. So this means you open this bracket x plus vx into x plus vx. So if you have this, you can go further by saying x times x is what? X squared. You open this bracket. This is going to open this. X times x is x squared. X times dx is what? X dx. Are we following? So now dx now times x plus is going to be x dx also, and then dx times dx is going to be what? Dx squared. Dx squared. So having gotten this, then you collect your like times. Dx, x dx plus x dx will give you 2x dx, then plus dx all squared. So now, wherever you see x plus dx, you can substitute with what? This particular arithmetic we've just done. X plus 2x dx plus dx squared. So now, we can say now, substituting it into this formula, you have what now? From here, you can go further by substituting it into this formula, which says dy of dx is equal to this space we said we've gotten our f of x to be equal to x squared, and then we have gotten our f of x plus dx to be equal to x squared plus 2x dx plus dx squared. So now we said our general formula. Now we are substituting into our general formula, which says dy of dx is equal to limit as dx tends to 0 now. So your limit as dx tends to 0 of what now? We said the formula says what? F of open bracket x plus dx minus what? F of x all over dx. So these are general formula. So in order to substitute this now, we will have limit as dx tends to 0 of, we said what's our x plus dx? This is what we've gotten as our x of dx. Then you say x squared plus 2x dx plus dx squared. So now this particular f plus dx, we've already gotten it to be this. We have inserted it here in bracket Then you have your minus. Now, what's your f of x? We said our f of x is what? X squared. F of x is equal to what? F of x squared all over dx. That means wherever you've seen f of x in your formula, you will substitute it by what? X squared. Wherever you've seen f of x plus dx in your formula, you can go further by substituting with what? X plus 2x dx plus dx squared. That's exactly what we did here. We have seen our f of x plus dx, we've gotten it to be x squared plus 2x dx plus dx squared. And then now we substitute it back into the formula, which says wherever we see it, we write it like this. And we've inserted it. And then wherever we've seen f of x, we insert it to be what? X squared. So you close your parentheses. Now, dy dx now, your dy dx will now be equal to limit